Today we will learn how to calculate the length of an arc. I have two problems here. The first one will calculate the length of an arc using measurement in degrees. We'll measure the angle in degrees. Later we'll measure angle in radians. So let's draw a circle. Okay, this is a circle. And here we have what is given. We have a radius given. Radius is equals 6 meters, and it creates an angle of 72 degrees. So let's say something like that. Okay, so I'll mark it with different color. So this is our arc. Arc is just a part of the circumference, and the length depends on an angle, right? This angle here is equal to 72 degrees. So you know that to calculate the whole circumference of a circle, the circumference, the total length, is given by the formula 2 pi times r, and r is the radius. So the whole circumference would be 2 pi times 6. So it would be like 6 times 628, because 1 pi, if you remember, 1 pi is 3,141 approximately, because it has infinite decimal. But we can remember just this 3.14. That's fair enough. Okay. So it would be the whole circumference. Maybe I can show you with a calculator. So it will gonna be like 6.28 times, because 2 pi, 1 pi is 3.14, so 2 pi is 6.28 times 6. So the total circumference equals, one more time, 37.68. So we write 37.68. That's the total one, the total length. But you know, the arc, as we showed here, arc is just a part of a circle. So arc will be smaller than this. It cannot be as big or bigger. It has to be smaller because it's just a part of a circle. So how to find out how much shorter it will be? We need to create a kind of a ratio depicted by the angle. So angle is 72 degrees. But how many degrees we have in total? In the circle is 360. This is the angle. The full angle of a circle is 360. So we need to know what is the ratio of this arc, this angle created by an arc, to the total circumference. Because this will tell us how much smaller. This ratio tells you how much smaller is this angle than that one, and it will tell you how much shorter is arc than a whole circle. That's why we need to create this. We always write on top in a numerator the angle which is given by arc or a sector, and ratio to the total. So then we multiply it by the formula of 2 pi r. It will tell you how much shorter will be, that is the total, so how much shorter will be the arc. So look at this number, 72 over 360. We can simplify this fraction. You have to find the common divisor. You have to find a common divisor to divide it. So if you can keep dividing by 2 or 6 until you will find it's 1/5. So we see that this ratio is 1/5, which means that this arc will be 5 times smaller than the whole circumference. So we need to multiply 1/5. Oh, you know that 1/5 equals 0.2. So 0.2 times 37.68. It will be 5 times smaller. So we see that the total circumference of no the length of the arc is 1/5 of 37.8. So how much it is? How much is it? You can divide it by 5 and you'll get 7.5. Yeah, so this arc has length approximately 7.5 meter, and we have solved the exercise. So remember, you need to create the ratio of the angle of the arc to the total angle of the circle, to the full angle, always smaller to the total, which is 360. Okay, so this one we have degrees, but how to solve it when we have angle given in radians? Let me first erase our calculations. Okay, so again we'll draw the circle. This is our big circle. Now the radius equals 5 meters. This is our radius, 5 meters. And we have an angle. And this time this angle is not right angle, not straight angle. It's given by 2 pi over 5. 2 pi 5 radians. So we know that radian is approximately 57.5 degrees. You can remember this, but how will we obtain it? It's good to know how to obtain this figure, 57.5 degrees. So radian was obtained from the relationship of diameter to the whole circumference, just like pi was derived this way. So we should remember that 1 radian equals to 360 divided by 2 pi. That's how you will obtain this 57.5 degrees. So remember that 1 rad. So how many radians do you have in 360 degrees? 2 pi. So if you say 2 pi radian is a full revolution of a circle. That would be 2 pi radian. That's the full one. But if you want to change it to degrees, you have to divide it by 2 pi. Then it will change it to the degrees. But if you want to change degrees to radians, you have to multiply them by 2 pi. Okay? So you know it. So now we are able to solve it. You will use exactly the same formula. You will create your ratio, but this time this ratio will be expressed by radians, ratio of this angle created by the arc. Again, this is your arc. Make it even thicker, so you see the red color. This is the arc, not full circle, just that part. All right. So this ratio of that angle to the full angle, and to full angle is 2 pi radian, full angle. Okay, so we write 2 pi divided by 5. Here we write radian because it also radian next to it. It's not just pi, it means radians. Then divided by 2 pi. 2 pi radians. Because 2 pi radians is the whole circumference expressed in angle, which means 360 degrees. So we have part to the whole, and this ratio will tell you how much shorter will be the arc in relation to the whole circle. So we multiply it by 2 pi r You know, this is formula for the total circumference of the circle. So you see what we got here. We can cancel out a few things. I'm going to take the red color. Few things we can be cancelled out. You see we have radians. Radians can be cancelled out. And now you have 2 pi here, and you have also 2 pi. So this will cancel out. So what stays is only this 2 pi divided by 5 times r. Just like in the first example, we see that the arc length in this case will be 5 times shorter than the total circumference, because total circumference equals 2 pi times r, but here we also see over 5. So it's gonna be 2 pi times 5 divided by 5, because radius here is 5, so we can cancel out 5, and we see that the total circumference of this not this length, the total length of this arc is just 2 pi, which means is approximately 6.28 meter, and that's the solution. So we solved it. Very similar way, both for angles expressed in degrees and radians. So remember, the very crucial is to establish this ratio first, and later you multiply it by the total circumference. It will tell you how much smaller is this arc from than the total circumference. But remember, when you write it in 2 pi, it often cancels out. The radians will cancel out, and pi will cancel out, so it will be much easier to calculate. Remember those rules. Okay, that's all. I hope you find it helpful, this class. Thank you very much. See you in the next one. Bye bye.